Hello geometry students, it's Mrs. Shomri and I'm here with you again for another day of three-dimensional geometry. You should begin to notice that our geometry packet, we're getting towards the end of it. So next week we're going to start our unit on circles. So we're going to finish up geometry 3D this week as best as we can. So today I'm going to go over this question, problem number 2. It's on page 24 in your packet. It's a snow cone question. And it's got a lot of different twists. And what I'd like you to do is this. I'm going to go through this question with you. There are more questions to follow. I'd like you to try them. I'd like you to practice them. I'd like you to see if you can't distinguish what's going on with them. And then if you have questions, let me know, and I will create a video to help us go through each of those questions that we need help on. And then I'll post the answers at some point, and you can take a look and see what we still need to work on. Now, if you were taking the Regents this year, these would be your questions at the very, very back of the Regents exam. These would be worth 4 points, possibly 6 points, and you get partial credit along the way, depending on what the state says according to their rubric. So I'm going to go through this question today, and it'll probably take us the entire video. So I'm going to start, and that will be that. Okay, so number 2 says, a snow cone consists of a paper cone completely filled with shaved ice and topped with a hemisphere of shaved ice, as shown in the diagram below. So right there, I'm going to say, oh, look at that. It's a cone and a hemisphere. Okay, so those are 2 important vocabulary words, 2 words that we've already found the volumes of. We know how to do that. So we're going to realize very quickly why this problem is so involved. Because it is a cone plus a hemisphere. It's a conjoined volume. Okay, plus as we read along, we're going to see a couple of other things that are going on with this problem. Okay, so if I'm looking at this, I say, okay, the inside diameter, well, stop right there in your tracks. Diameter, we never use diameter for any of our formulas. So we take that diameter of 8.3 and we divide it in half, divide by 2, and we get a radius of 4.15. And we're going to use that radius when we come over here and we do the problem and we find its volumes. Okay, so I'm going to write that over here. So this radius is equal to 4.15, which is also the height of my cone. Okay, so what do I have? I have a conjoined figure, and my conjoined figure consists of a hemisphere on top, plus a cone. Okay, so a hemisphere plus a cone, and we've done this, so you should be okay with this. All right, so I'm going to go to the back of my packet and find on the reference sheet the formula to calculate the volume of a hemisphere. Now, a hemisphere is half of a sphere, so it's 1/2 of a sphere, which is 4/3 times pi times my radius cubed. And to that, we're going to add on the volume of a cone, which is 1/3 times pi times my radius squared times my height. Okay, so I found those formulas on the back of the packet. Okay, left side on the bottom, here is a sphere. Okay, so half of a sphere is a hemisphere, and right underneath it is the cone. Volume equals 1/3 pi r squared times height. And notice that in the sphere, your radius is cubed, and in your cone, your radius is squared. Okay, so I'm going to start putting those numbers back in and calculating the volumes. Okay. So if you had read ahead, which I didn't do yet, let me just go through the rest of the problem with you. It tells us the height of the cone is 10.2 centimeters, so we're good. We're centimeters and centimeters. And then down here is where it starts getting squirrely. The desired density of the shaved ice is 0.697 grams per centimeters cubed. Okay, not too bad. And so now it's a density problem as well as a conjoined volume problem. So I'm going to write down the density formula here. Density is equal to mass divided by volume, okay? And you need to realize that that formula would not be on your formula sheet. And the cost per kilogram, now there's an issue because we start with kilograms, but our problem was given to us, our density is in grams. So we've got grams and kilograms. So now we've just introduced a conversion into the entire problem as well. And then the cost is $3.83. Determine and state, those are our two action words. Okay, determine and state the cost needed to make 50 snow cones. So we've got a lot of different things to do, but that's why this problem would be worth a lot of points if we were taking it on the regions. Okay, so going back to where we began, okay, to find the volume of my hemisphere, I'm going to start plugging in these numbers. So volume is equal to 1/2 times 4/3 times pi times my radius, 4.15, to the third power, or cubed. Now, depending on which calculator you have, you're going to do this problem in a couple of different ways. So if you have a graphing calculator like me, you're going to do 1 divided by 2 times 4 divided by 3 times pi, use your up arrow, second up arrow, times 4.15 to the third power. If you do not have a graphing calculator, you're going to use 3.14159 for pi, and you're going to multiply 4.15 times 4.15 times 4.15. However you get there, your volume for the hemisphere should be 149.693 centimeters to the third power. Okay, so double check your work. Okay, on the cone, you should put in your numbers, 1/3 times pi times your radius, 4.15 squared, and then we're going to multiply by the height of the cone, which is this number 10.2. And again, that all goes into your calculator. Notice that my problem is not in terms of pi, so I'm multiplying the pi, make the pi go bye-bye. And I am multiplying 1 divided by 3 times pi times 4.15 squared, that means multiply it twice, times 10.2 to get your volume of the cone. And that volume is equal to 183.9606. And again, we're still in centimeters cubed. And because it's a conjoined figure, we are going to add those two together in your calculator, and your total volume is equal to 333.6536 centimeters cubed. And notice I'm not chopping off any of those decimals because I do not want my answer to be off at the end, and it could be if you decide to round too early. Okay. So that's the volume portion of my problem. Okay, now rereading down at the bottom, it says that the density is equal to 0.697. So over here, I'm going to organize. Density is equal to mass divided by volume. I know the density is 0.697 grams per centimeters cubed. Mass divided by volume, and your volume is this volume that we got from over here, 333.6536. Now this is in centimeters cubed, so if this density was in grams per centimeters cubed, then my mass must be in grams. Okay, so I'm going to set that up as a proportion, and I'm going to cross multiply, which means I'm multiplying that number times that number to get my mass. So into the calculator I go, 0.697 times 333.6536, and I'm going to get a mass of 232.5566, and remember that's your answer in grams. So that's the first part, or should say the next part. Okay, so now we've worked the density. The problem goes on and tells us about the cost per kilogram and 50 snow cones. So I'm going to take this mass and I am going to multiply by the cost, which is 3.83. Okay, into the calculator I go. Now this number should already be in your calculator, so don't re-type it in, just piggyback on top. Go multiply times $3.83, and you should get an answer of $890 and 6.91. That's not money. But remember, we're not chopping off decimals yet, okay? Even though it's not an appropriate answer for money, we're going to round at the very, 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 very end. Okay, so these are very expensive snow cones, but remember, we want our answer in kilograms, okay? And right now we're working in grams, okay? So now we want to determine and state the cost of 50 snow cones. So I'm going to take that $890.691, which is not money, I know. And we're going to multiply that by 50, okay? 50 is my 50 snow cones. So in your calculator, you're going to piggyback on or multiply times 50, and you're going to get an answer of 44,534.59. Now, nobody in their right mind is going to pay $44,534.59 for 50 snow cones. But remember that last little part at the end, our answer has to be converted, because this is the price per kilogram, okay, for a kilogram of them. But we want our answer. So we're going to take that answer and we're going to divide by 1,000. And why did I choose the number 1,000? Because there are 1,000 grams in a kilogram. So if I want my answer in kilograms, I need to do that conversion. Now, sometimes those conversions are on the back of your sheet, on your reference sheet, okay? And this one is not, okay? Well, actually, it kind of is, okay? If you look here, okay, and if we were in class together, we'd have a little lesson on the beauty of the metric system. Okay, right here it says 1 liter is 1,000 cubic centimeters. Okay, so cubic centimeters is kind of sort of the same level of units as your grams. Okay, and 1 liter would kind of be like your kilograms. So we take that and we divide by 1,000 and we get our answer. Okay, 44,534.59 divided by 1,000, and the cost of the cost of 50 snow cones is going to be $44.53. Now that makes more sense, that 50 snow cones would cost $44.53. Okay, that's a little less than $1 per snow cone. Okay, if I'm going to sell my snow cones now for $2 each, that makes sense that I'm going to be making money. You wouldn't be making money if your snow cones each cost, 50 of them cost $44,000. Okay, so that little conversion is in there, making our life a little bit more complicated, but not too bad. Okay, so that's our one problem for today. And remember what I said, make sure you can do the basic problems on calculating densities. Okay, like this problem up here. Okay, number 1 on page 24, the ones on the previous page. I will post the answers and all will be well. There's some more back here. Okay, I'd like you to try those. Sometimes they're good practices. They're good exercises in organizing your work. Okay, these were all the more difficult questions from our Regents exam. Okay, there's the same question again if you want to practice it again. That little snow cone question. Okay, and then my all-time favorite question of all times. Okay, on page 31 of your packet, this is the water tower question. So I think maybe tomorrow I'll come back and do the water tower question with you, because it's a lot of fun. Okay, so that's where I'm going to end today's video. Okay, at 12 minutes. I think that's more than enough with one problem. So I'd like you to have a wonderful day. Okay, and I will see you tomorrow probably for one more short, quick little video on that water tower question, and that will be totally optional for you. So, again, have a great day. Talk to you soon. Bye-bye.